Okay. Are you getting my voice, everyone?
Yes, ma'am, sir.
Okay.
Yes, sir.
Someone has messaged me that uh, he is in a waiting room. Just wait. Whose mobile number is end with 443? Have you joined or you're uh,
Yes, sir.
okay, you joined, no? Okay, fine. I thought you are getting problem to join. Okay, no issue. Uh, Hello students, this is our first lecture. I am Professor Kapil Wag. I am ME in Computer Science Engineering, and I recently joined your college, and I have been allotted your subject, that is system programming and operating system practicals, right? So the practical I will teach you, right? So I think this is your first practical, or any particular practical of this subject is already covered. Anyone please unmute and answer.
First one, sir. First one.
Yes, sir, first.
Okay, first one, no issue. So today what we will do, I will show you first the practical name that is actually in the program. Just wait, I will share you one file. Okay, everyone is able to see the screen.
Yes, sir.
Yes, sir.
Okay, fine. So this is your first practical. As the concepts of what is assembler, compiler. So these things, of course, these things you have already seen in this subject, right? Mm, So the practical number one, that is what you have to do is that design suitable data structures and implement pass one and pass two of a two pass assembler, right? So you know the concept of uh, assembler and the one pass and two pass. These things means why these two passes are required to generate the machine code. Okay, so in theory part it is already covered, and meanwhile while teaching the practical I am also elaborate those things to you. Okay, so for pseudo machine is that any target machine, right? So implementation should consist of a few instructions from category and few assembler directives, right? So the output of pass one. So we will see this first. Implementation should consist of few instructions from category and few assembler directives. Means what you have to do is that the input file you have to present that will contain the code of assembly language, right? And what you have to do, you have to convert those input file into various data structures. That is, data structure means what? Data structures kya rahega isme? Data structure will be the different tables that you already learn in the subject, theory subject, that is mnemonic opcode table, intermediate code, then literal table. Okay, so we have to find the various literals into the input file, that assembly code, right? Various mnemonic opcodes we have to find, right? That read, add, like these things included in the assembly language. So we have to separate them in the different data structures. Literals होगा तो वो literal के table में जाएगा, right? So mnemonic opcode होगा तो वो उसमें जाएगा, symbols होंगे तो वो symbol table में जाएगा. So these things we have to do in this practical. Okay, so the output of pass 1 should be the input for pass 2. Okay, means these data structure we will convert, we will find, that is symbol tables, intermediate code file, mnemonic opcodes, literal tables. So these data structures will be the input for the next program, that is pass 2. Okay, means these two programs are included into this practical 1. Okay, see this practical 1 contains two programs, means you need to do the two programs for that, right? This is the first program that we will learn later on. First we will go to some theory part. Okay, so some revise like this you can do, then we will concentrate on this program. So what this program says is that the first program's output, okay, that will be the input for the next program. Okay, so this is the first program, that is pass 1. Getting it? So two passes are required, not to convert the assembly code into the machine language code, right? Two passes are required. So there is a program for pass 1, okay, and another program for pass 2. So by executing these two programs you can get the machine code for the particular given assembly language, right? So we will first program is that you have to just convert, you have to just make some data structure. Okay, so output I will show you first. Okay, so here you can see this is the input file. Input I also printed in the program, right? So this is the input file, that is assembly language code. This is okay. So you can see the various symbols are there, then various mnemonic opcodes are there. Okay, so the single quote values, that are the literals. Okay, so literals are there, symbols are there. Okay, so you have to separate them in the different tables. Okay, so you can easily then make the convert it to the machine code, right? So here the output of this first program, the first output, that is opcode table, that is also called as mnemonic opcode table. Okay, there is some problem in this. Yes, anyone is having doubt? Okay, so this don't go to this spelling, this is actually, this is the printing mistake. Okay, so this what this is actually the mnemonic opcode information. Okay, so this is mnemonic opcode table, right? And if we go to down, then on this literal table, okay, this should also be generated. Okay, and this is the pool tables. Okay, that is which will contain the literal numbers, right? So why I'm showing this first to you, because you should understand what we have to do actually, what output we require at the end. Okay, then you will get interest into implementing such a type of programs to get the particular output. Okay, if you don't know what output you required, then you won't get any interest, as well as you won't understand the concept. Okay, or understand the code. So this is your input file, and this output you will require. Okay, so I will share one PDF to you now. Just wait. Okay, just give me 2 minutes. I will find that PDF and share it to you. Okay. Okay, I'm not getting the option to share PDF, so we will go through the screen sharing. Okay, now are you able to see this screen? That assembler mnemonic operation codes.
Yes, sir.
Okay, fine. Okay, so we will see some concepts that is required for our first practical. Okay, then we will move to the practical, right? So first, what is assembler? That is written in front of you, but you can tell me in your own language, right? So anyone please unmute and tell me whatever definition you know. This is my definition of assembler. So which definition you learn? Okay, so anything is having mostly few definitions, right? So it depends upon the different books. Uh, so can anyone please unmute and tell the what is assembler? Or you can also say anything about the assembler. I don't want the exact definition, right? Just what is the assembler? What is the work of assembler? What is the function of assembler? What is the task of the assembler?
Assembler can convert assembly language into machine level language.
Okay, and I'm not able to see your name here because it is a screen in front of me. So who is answered that? What is your
Aditya.
good name? Aditya. Okay, Aditya Tadekar.
Aditya gained.
Okay, okay, good, fine. Assembler means what is the function of assembler? To convert the assembly language into the machine language. So that's why it is called as assembler. So an assembler is one of the system software, right? So which acts as a translator. It converts the assembly language program into the machine level language. Okay. So here in the diagram, you can also see the input is the assembly language program and assembler is required, and you can get the output as a machine level language program. So why we need to convert this assembly program to the machine level language? Why computer can't be able to operate on assembly level language program? Hmm? Why it is needed to convert to the machine level language?
Because computer can't understand assembly language. It only understand a binary language, which
Great,
is machine
great.
language.
It's simply great what you answered. So very good answer. Bye. What is your good name? This is different voice, right?
Uh,
Now this is not Aditya. Who is
Avdut
this?
Chavan.
Okay, good.
Avdut
Very
Chavan.
nice answer. Very nice answer. So I worked in the previous college. No any student could give the answer of this question. So very good. Congratulations. Mm, So the answer is the computer knows only the binary language, binary inputs, that is 0, 1, right? So combination of zeros and ones. So that's why we need to convert it to the machine level language, right? Now next is mnemonic operation codes. That is in simply you can call it as mnemonic opcodes, right? So assembly language uses mnemonic operation codes for machine instructions instead of numeric operation codes. Okay, so why this mnemonic operation be required? Because assembly language makes use of this, right? So what finally we have to do, we have to convert this assembly language program into the machine language, right? So we have to get some particular uh, keywords, or you can say that input from it. Okay, something we have to do, no, something we have to design. That means some uh, uh, pro forma we have to do, prototype we have to form to convert it into the machine level language. So what we can do, if you think, uh, we can distribute it into the different tables, and according to the values of those tables, we can easily then convert it into the machine language. Okay, I will show you one diagram, okay, at the end, uh, so you can easily be able to understand so why we are separating these things, right? So next one is symbolic operands. So assembly language uses the symbolic names to represent the data address. Okay, the assembler performs memory bindings to these names by reducing the task of the programmer, right? Like these examples are num total. So so by using this keyword, this can be used as the codes for the assembly language. You can also see the in the mnemonic, of course, that this add, so these things used to make the addition of two numbers, like such a type of programs in assembly language. Okay, and mostly it is used to work on the microprocessor. Okay, so I never learned the microprocessor as I graduated in the information technology in my university. So you people is having subject of microprocessors, you better understand. Okay, so by using this add and this assembly language, you can also operate, we can also operate the microprocessors, right? And those registers and the particular code, that how to write that to move the value from one register to another register. Okay, so these things you better know than me, that microprocessor like these things. Okay, so this next one is the data declaration. So in assembly language, data can be declared in a variety of notations. Okay, like, okay, that this one is I was talking about just now, that is, if you can write like max bc 100. Okay, so 100 is literal in this case, getting it? So because it is written in the single quote, right? So here one simple assembly language program. Okay, okay, many of you, means almost all of you know these things, but why I'm telling this, I just want to revise these things, because this is mostly or almost all these things are required into your first practical programs. Okay, so there are different mnemonic opcodes present in assembly language, that are stop, add, sub, mul, that is subtraction, multiplication, like these things. So move r. Okay, so move into a register. Okay, and move m means register into the operand, right? Then there is some comp function, comp code, that is means compare, it is used for the compare, right? uh, so uh, next one is bc. Okay, bc is the branch on the condition. Okay, div, that is divide registered by operand 2, means you have to operate these things. Okay, so last one is the print, and before that you can say also read. So one thing you can observe here, that is here every mnemonic opcode, right? Every mnemonic opcode having its own numeric opcode. Getting it? Here you can see each and every mnemonic opcode having its corresponding numeric opcode. Okay, so this top is having numeric opcode, that is 00. Okay, for add it is 01. for subtraction 0 2. Okay, like this each and everything is having its own numeric opcode. Okay, so read, there is 0 9. Okay, right? So why I'm telling you this? Hmm? So what is the use of what use we can make from this numeric opcode? Okay, because as the student, I think name was Jawan, so what he said that we have to computer can't understand the letters like these things. Computer understand only the binary language, that is zeros and ones. Okay, so here in the rectangle part, you can see the numeric opcodes for such mnemonic opcodes. Okay, so by making use of this numeric opcode, then because this data is present in the decimal format. Okay, so we can't convert this stop, add, subtract, move, these letters or these words into the binary language, right? So we can convert the decimal numbers very well into the binary level language, right? So here we can make use of this numeric opcodes present for these mnemonic opcodes. Okay, so for take example of read, that is second last. Okay, so that numeric opcode is 0 9. Okay, so if you have to convert it into binary language, we can easily do it. Okay, so along with means it doesn't require its own only, means it doesn't require alone itself, it required some another data, okay, with it, right? So uh, now you can see here uh, at this part. Okay, what this is the different registers used in assembly language, right? These four types of registers are used. That is if code is written like AREG, what that means, that means this is the register A. Okay, BREG, that means it is a register B. Okay, C register, and similarly C register and D register. Okay, and there are some condition codes also. Okay, so whichever language is present, there are some conditions. Getting it? Any language is present, whether it is Python, whether it is C language, these object-oriented languages like C++, Java, the procedure-oriented languages like Pascal, C. Okay, so these languages require some conditions, right? So you can move your code ahead. So here the assembly language also has some conditions like LT, LE. So these codes are given. Okay, so less than, then the LT code is used. Okay, less than or equal to, then LE code is used. Okay, then equal to is there, then EQ is used. Greater than, for greater than, GT is used, and GE greater than or equal to. And for any, you can use the keyword like any. Okay, so we will move to the next page. Okay, so now this is add AREG comma A. Okay, so what is the meaning of this? Add the content of A into the content of A register. Okay, means here A, this first A. Okay, just wait, I will show you by making use of annotations. So this A, now this is not the register. Okay, this A is not the register. This A is a symbol. Okay, so here, or you can say it as a variable. Okay, so any data you can store into this A, that is, suppose this is you can, if you store the value 10. Okay, so where this 10 value will go? To the register A. Okay, similarly move AREG comma A, so move the content of A into the A register. Okay, so very simple. This is where the student make the mistake in such a kind of code, that mostly student do the mistakes in just wait, I will show you. Means suppose this is move, means it is moving the data. So moving the data from here, okay, or move the data from here to here. Here mostly the student makes it uh, gets confused, okay, and do some mistakes. So this thing you have to understand, okay. So if move r is there, then where the data will go, from right hand side part to left hand side part, or left to right, okay, right to left or left to right. So that you have to understand. The other things are very simple, okay, and it name suggests, like suppose this is add is there, then you know you have to add the contents. Move r is there, you have to move the contents of register, okay. Move m is there, you have to move the content of a register into the symbols, okay. Got it? So next one is the compare. Hmm. So similarly, compare is there. Then there is a branch code is there. Okay. And so what is the use of this BC LT comma loop? Means transfer the control to the statement labeled loop. Okay. If condition code LT is set, right? Then only you have to transfer.